In this session, we're going to be talking about pi, radians, and the circumference. To understand any of these things, we have to remember what a radian is. I've drawn a circle and its radius, and now I'm just going to go ahead and wrap the radius around the edge of the circle. We said that there weren't a whole number of radians in a circle, so let's go ahead and show you exactly how many we can fit. As we can see, we can fit exactly 6 radians around the circle. But we do have this little piece left over. That means an entire revolution contains somewhere between 6 and 7 radians. If we measured this leftover angle really carefully, we would see that there would be just over 0.28 radians left over. Therefore, the total number of radians in a circle is approximately 6.28, as I'll write down now. This number is a transcendental number, and no matter how accurately you measure, you're never really going to find a pattern in it. It just really goes on forever. Because writing it all the time would be really inconvenient, we define it as tau. Let's get rid of some of the markings we don't need for now. Now at school and throughout your life, you're actually pretty unlikely to see tau very often. This is because historically we actually used to measure angles using the diameter and not the radius, as I'll show you right now. As you can see, the angle covered by one diameter is double the angle covered by a radian. So we can ask how many of these diams we can fit into a whole revolution. Careful measurement shows us that we can fit half as many diams into a revolution as we can radians. Now this number is so important that you're going to see it pop up all over mathematics. We call this number pi. Now we just use the fact that a diam is just twice as large as a radian to rewrite it like this. I'll also go ahead and clean this up and leave only the important information. And I'll also write out a few digits of pi just for your convenience. Later on, we'll show you how to generate these digits yourself, but for now it's enough to know that you could just accurately measure the circle to find them. Now this is going to serve as a very useful formula to help us convert between our different measures of angles, as you'll see in the next section. Let's start by writing out the important results. Now this is just saying that 1 rev is the exact same thing as 2 pi rad, which is the exact same thing as 360 degrees. By using this, we can convert any angle measurement to any other angle measurement, as we're about to show you now. Let's start with 1/4 of a revolution. Let's try converting this angle into degrees first, then into radians, and then back again. So let's start by converting this to radians. Let's start by writing the fact that 2 pi rad equals 1 rev. It turns out that we don't need to write the 1 there because 1 times anything is just itself. So 0.25 of a revolution is just the same thing as 1/4 of a revolution. Now we know that the rev is the same thing as 2 pi rad, so we might as well go and replace that. Now this can just be simplified to pi on 2, so therefore we can write this in its final form. So this gives us our final conversion. So let's get rid of this working out. Now this time we'll start with pi on 2 rad and try converting it into degrees. We'll start by copying it out first. Now we know that 2 pi rad is the same thing as 360 degrees, so let's just solve for rad again. Now I did this pretty quickly, but we just started with the fact that 2 pi rad is 360 degrees, then we divided by 2 pi, and we just crossed out the 2's. So then we were left with the final result, which is just 180 on pi degrees. So let's just go and move this away into the corner. So we know rad is the same thing as 180 on pi degrees, so we can just make that substitution. First you see that the pi's cancel out, and we know that 180 divided by 2 is just 90, so we can write this in its final form. So this gives us the final conversion for this particular angle. So let's go ahead and write that one too. Let's go ahead and get rid of this working out as well. Now an angle of 90 degrees is a special angle that we call a right angle, and to denote a right angle we usually use this symbol. Now there are a bunch of other angles that I'd like you to see, so I'll go ahead and draw them on too. To help you quickly find angles and radians, I'm going to give you a bit of a tip. Wherever you see the number pi, I want you to read it as of a semicircle. Let's start with this one. This is half of a revolution. Since this is just a semicircle, this is one of a semicircle. And half of 360 degrees is just 180 degrees. This is a third of a revolution, so it's 2/3 of a semicircle. And a third of 360 is just 120. This one's a third of a semicircle, and therefore a sixth of a revolution. And 1/6 of 360 is just 60. This last angle is 1/6 of a semicircle, and therefore it's 1/12 of a revolution. And a 1/12 of 360 is just 30. You're going to have to be pretty familiar with all of these angles, so it might help you to do a few of these conversions yourself. So there is one last thing that we should say though. Let's put our radian circle back on the page for a moment. We define the circumference as the outer edge of this circle. We already said that 1 rev was equal to 2 pi radians. So if we said that c was the length of this circumference, then we know that we are going to fit exactly 6.28 radiuses around it. Therefore, we can also say that the circumference is equal to 2 pi times the length of the radius. Since we know that the radius of a circle is just twice its diameter, we can also write this as pi d as well. That means if you increase the radius of the circle, the circumference is going to increase proportionally. So if you double the radius, you're also going to double the circumference. And that completes our discussion on pi, radians, and the circumference.